A union B are those elements in A, also in B. So we see both A and B are shaded. And this is A union B. So A intersect B is the intersection of the elements in A and also in B, this shaded area. A minus B are those elements in A but not in B. Right? In A, not in B. So this is shaded area. A subtract B. And then you can think about B subtract A. B subtract A would be this part, right? The elements in B but not in A. Well, what's A complement? A complement are all the elements in U in the universal set but not in A. We see except the set A, all other, the rest of the rectangle is shaded. So the shaded means the complement of A. And of course, we can union finite many sets. Right? We can union 3 sets, 4 sets, so on and so forth. So if we have 3 sets, A, B, C, so A, B, C, this is a union of A, B, C. The intersection of A, B, C are the elements, in A, in B, and in C. A union B equals to B union A. A intersect B equals to B intersect A. So we call this commutative. So that means the union is commutative, which means commutative means the order does not matter. Like when we talk about operations, right? Plus is commutative. 1 plus 2 equals 3, 2 plus 1 equals 3. And the multiplication are commutative, right? 2 times 3 equals 6, 3 times 2 equals 6. But subtraction and division are not commutative, because 3 divided by 2 is different from 2 divided by 3. 3 minus 2 is different from 2 minus 3. So A union B equals B union A. A intersect B equals B intersect A. So union and intersection are commutative, which means the order does not matter. Associative law is like this: A union B, union C. We can union B, union AB first, or we can union BC first, right? And A intersect B intersect C, we can union AB first, then intersect with C, or we can intersect BC first, then intersect with A. All right. Distributive: A union parentheses B intersect C. That equals to A union B. They intersect with A union C. Right. And A intersect B union C equals to A intersect B, then union with A intersect C. Okay, parentheses always has higher priority, right? When we see here A union B intersect C, we would do this inside parentheses first. We would intersect B intersect, we would calculate B intersect C first. Okay, parentheses shows higher priority. Okay, complement of unions and intersections. So the complement of A intersect B equals to A complement union B complement. This kind of law takes a little time to digest, all right? And hopefully we have time to use some examples. And the complement of A union B is the complement of A intersect with the complement of B. Okay, people call this De Morgan's law. De Morgan's law. Okay, somehow we did not mention this. It's a D-E-M-O-R-G-A-N, De Morgan's law, a person's name. So he proved this. So later on, let's try the classwork. Let's try to calculate some of this to verify those laws. And also we can index sets. We can index a set. So once we're working with more than 3 sets, we want to index them. Otherwise, it's very easy to get confused. Instead of labeling each set A, B, C, we labeling them as A1, A2, A3, right? So A, B, C, we would rather, let's say this is similar to when we talk about higher dimensions, right? With 3 dimensions, we talk about X, Y, Z. But when we talk about 4 dimensions, 5th dimension, 6 dimensions, we don't want to use X, Y, Z, adding more different letters. We would rather call X1, X2, X3, X4, right, represent 4 dimensions. If we need a 5th dimension, we'll add X5, 6th dimension, X6, so on and so forth. So it's easy to trace, it's easy to follow up or trace back. So suppose we have these n sets, A1, A2, A3, up to AN, we have n sets. Then the union of all of them, right, we represent with X in every set. Right? It's the union of all elements in these n sets. How do we write it? We write it in a shorthand notation. So we said, okay, the member in each set, and the set notation we use AI to represent. And then this I is called index. This I, you see I is the first letter of index. So this is how we index a set. Then we say, okay, I goes from 1 up to n. Right? This is much shorter than we write, okay, X in A1, X in A2, X in A3. Right? This is a shorthand notation. So we write X, the members in each set, all right? And AI, so as the index, I goes from 1 up to n. Okay, just get familiar to this index notation. The intersection, we will do the same thing, right? We'll say X is in AI. The language-wise, for union, we say for at least one set, right? Because it's a union for at least one set, AI. And this, the intersection, we say the members here are for every set. Because intersection, the elements has been in each set, right? For every set. So this set collects the members in every set, the same element in every set, right? The union collects all the elements in each set. So use the language, the first one, the union for at least one set. And for the intersection, we use the language for every set. We use this index notation in sigma notation, right? Sigma talking about, okay, we want to add n numbers. Instead of writing A1 plus A2 up to AN, we write sigma AI, then let I run from 1 up to n. Right? So similar idea. A similar idea. One example is this. We want to add up 2 raised by I goes from 1 up to 6. That means we want to add up 2 raised by 1, 2 raised by 2, 2 raised by 3, 2 raised by 5, 2 raised by 6, right? And with this notation, we want to use the union. We have a shorthand of union notation. Instead of writing A1, union A2, union A3, up to union AN, we write a big fat U. So union of this AI, similar to the sigma notation. Right, the big U, big union, with union of all the sets AI, and the I goes from 1 up to n. Okay, similar to the sigma notation. Similarly, for the intersection, which is upward U, intersect AI and let I go from 1 up to n. If we have 5 sets, we use B, B1, B2, B3, B4, B5, right? The union of I, where I goes from 1 up to 5. If we name the sets C, C1 up to C6, we have 6 sets. We would if we talk about intersection, we can write as the intersect Ci, let I run from 1 up to 6. All right, anybody has any questions? Okay, if not, let's go to classwork to see what we have to do. Classwork. Okay, okay, let's try one. Let's try 1A first. You may type in your answer in the chat. I remember you have a participation grades. Participation grades comes from your asking questions, answer questions. We'll try the class work. Okay, right. Okay, I like Moises' answer. Moises' answer with A union B. Okay, and Xiaoming, Patrick, you only type in this. Make sure your answer is for A union B. Okay, A union B, yes. A, B, C, D, E, and F. A, B, C, D, E, F. Yes, great. If everybody has any questions, feel free to ask. And the second one, A intersect B, right? 2, A intersect B, D and E. Good, yeah. D and E, or E and D, that's okay. Right? The members elements in the set doesn't have order. Okay, what about the 3? A minus B union B minus A. Well, let's figure out the A minus B first. What's A minus B? Try to use the right notation, right? Use a set, we use a capital letter. Element, we use a little letter, a lowercase letter. So A minus B equals A, B, C, right? Then what's B minus A? B minus A, F. So then we union these two sets, A, B, C, F. Great. Okay. Then 4, A intersects C. Empty set, yes. Then 5, A intersects C, which is an empty set, union A minus C. Well, what's A minus C? Oh, what is B minus A? What's B minus A? B minus A means the element in B, but not in A. Do you see F is in B, not in A? So that's F. B minus A is F. A, B, C, D, E. Right, it's only F. B minus A is F. So now we're in 5, right? 5, A intersects C is empty set. And A minus C is just set A, right? A minus C is a set A. Because element in C, then A intersects C is empty set. Union A minus C, which is just A. Empty set union A, which is just A. A, B, C, D, E. Yes, great, Samuel. For the rest of you, right, please, if you try, okay, you don't have to be right. Just try. If you have any questions, ask. Because this class is going very fast. In a month, we'll finish everything. If something bothers you, something confuses you, ask questions. All right, 6. We're still 1A, all right? 6. We have A intersect B, cross B. Well, let's think about A intersect B first. A intersect B, okay, we have DE. Then cross B. Cross B are ordered pairs. Let's see who can list all these ordered pairs. Okay, Wu has, so have DE and DEF. So we have 2 times 3. So we should have 6 ordered pairs. So DD, DE, DF, ED, EE, EF. Perfect, Wu. Yes, 6 ordered pairs in A intersect B cross B. All right, so the next one, I'm going to call people to show, all right? Because I want to check if everyone is understanding me. If you are here in the class, if I'm confused you, you know, that's not so good. So the next one, I'm going to try to call on people to answer. So if I do not call on you yet, and just wait, don't type in the chat, all right? If this person needs help, and then I will let you know. So now let's try B. So what do we have to do with B? B, we have to compute union intersecting difference of the following intervals. We're going to sketch them on a real number line. All right. So for the first one, we have a closed set because we have bracket 2 up to 5, union 3 up to 6. All right. Let me see whom I want to call. I want to call those people. Let me see here. Yeah, it looks good. Looks like everyone is participating. Okay, Ajah, Ajaiah. I need you guys to teach me how to pronounce your name right. Ajaiah, can you hear me? Ajaiah. Okay, so what is your answer for B? So number 1, B, I. So the interval of 2, 5, close the interval. 2, 5, and 3, 6. What's the union of those two sets? We're talking about real numbers, right? We wouldn't be able to list 2, 3, 4, 5, 6. That's only natural numbers, right? Real numbers means we have all those numbers in between two numbers. There are infinite many numbers. There are infinite many real numbers from 2 up to 6. Great. Yes, you're right. So we have a bracket, we have a closed set from 2 up to 6. Yes, that's it. Yes, great. Okay, 2, we're talking about the intersection of 2, 5, and 3, 6. Let me see. I want to see Amy. Amy, do you like to try? AMMY. Intersection of 2, 5. 2, 5 intersect 3, 6 is 3, 5. Yes, I agree with you. Yeah, it's a closed set of 3 up to 5. Right. Okay, great. Why is that? Okay, good. Amy, can you explain to Aidan why is that? I can make you guys presenters if you want to talk right on the whiteboard or something.
Isn't it because 3 has a closed intersection, and then for the first one, 2 and 5, 5 has a closed friend?
Well, let's use the whiteboard. Let's see, we have so I have, oops. So let's draw on this whiteboard, right? Let's use so 2, we have the first one, 2, so 0 is here. Let's see, we have 2 here. We have 4 here. We have 6 here. So the 2 sets we have 2, 5, 3, 6. So 2 up to 5, right? So this is a 5. And 3 to 6. This is a 3. This color is not so good. Let me try to use this. This is number 3. Then we have 3 to 6. Now, Amy, is this easier for you to talk about it?
Yeah, it's because the 3 is the only one that's involved, and it doesn't go up from 3, and it also has 5 involved in it, right?
Yeah, we see, okay, so we have these 2 sets, right? We have this one, we have this one. So the intersection unit is obvious, right? It's from 2 to 6. We see everyone is included in from 2 up to 6. So the intersection, do we see here? Do we see this part? I done? You see this part of it is in the blue in the set of 2 to 5, and also is in the set of 3 to 6. Okay, great. So for real numbers, always try to draw, always try to use a real number line. Always try to draw, to make it obvious. Okay, great. Now, okay, so 3, we have 2 to 5, subtract 3 to 6. Yeah, maybe you draw on your notebook. All right, draw on your notebook. So 2 to 5, subtract 3 to 6, which means those numbers in 2 to 5, but not in 3 to 6. All right, let me see. Oh, Samisha is in. Oh, okay, you can type in, Samisha. Samisha, do you want to try this one? 2 to 5, so the interval of 2 to 5, subtract 3 to 6. 2 to 5, subtract 3 to 6. That means those numbers in 2 to 5, but not in 3 to 6. This one is a tricky one. You know what? I'll open this one to everybody. You can type in. Okay, Patrick? You can type in the chat.
Oh.
Great. Nino, I agree with Nino's answer. Nino can, okay. Do everybody agree with Nino's answer? Bracket 2, comma 3, close parenthesis.
I thought it was just 2.
No, we're not only talking about natural numbers. We're talking about real numbers.
So you include the 3 because of the brace or bracket?
Exactly. Okay, let me try to draw this. Straight line. Yeah, let's try to draw it. Oops. Let's try. Oops. Let's draw the. Oops. Let's try to do this again. So let's see. This is 2. This is 5. Oh, you know what? What I wrote before probably give you wrong ideas. So I'm only going to draw the those numbers. So 2 to 5. How many numbers are in between? Like infinite many numbers, right? The infinite many numbers in between those two numbers. The infinite many real numbers, because real numbers contain those irrational numbers. There are many more irrational numbers than rational numbers. So from 2 to 5, the infinite many numbers. Then another one, let me use red color. So 3, another set is from 3 to 6. All right. Now we're trying to find the set from 2 to 5. So 2 to 5. So the set 2 to 5 subtract the set 3 to 6. That means those numbers, those real numbers, in the set of 2 to 5, but not in the set of 3 to 6. Nino is saying, okay, I see the numbers are here. Let me use green color. Let me use purple color. I see the numbers are here. Those numbers are in the interval of 2 to 5, but not in 3 to 6. Because 3 is included in 6. That's why the answer for this is bracket 2, but exclude 3. So use this close parenthesis. Does that make sense? Well, anyone has any question? Okay, now let's try to see the last question. Oh, actually, let's try another one. So what are those? Let's try to find this. Let's try to find 3 up to 6, subtract 2 to 5. Okay, anybody can try this one. Let's find the set of the interval 3 to 6, subtract 2 to 5. That means the numbers in the interval of 3 to 6, but not in the interval of 2 to 5. Okay, I done saying that's 5 to 6. I agree with you. That's right here. Not including 5 because 5 is in the set of 2 to 5. So we have open parentheses. That means, you know, the number can be very close to 5, but not 5 itself. It can be 4.9999, but not can be 5 itself. Then 5 up to, so this is number 6. This is number 3. So 5 to 6 with 6 included, and 5 is not included. Oh, this set means the number could be very, very close to 5. Like think about the number 5.000000, meanings of 0 in between the 1. Right? The number is very close to 5, but it's not 5. So excludes 5 because 5 is in the set of 2 to 5. Okay, anybody has any questions? All right, Maria, you have, do you have a question? Okay, all right. Okay, let's keep going. Okay, last one in B, negative infinity up to 2, union 1, union bracket 1 up to infinity. So let's see. George, do you want to try this question? George, are you here? Oh, number 1B, the last one, 4. This one, if you, let me see. This one. So the union of negative infinity up to 2, and with a set of 1 up to positive infinity. You also can draw this on the real number line. Right? We want to find the union of those two sets. Do you need help, George? Okay. Michael, can you help George? Right, negative infinity up to infinity. Right. If you draw, you see from 1 to 2 is the intersection of those two sets. Right.
I
You
wanted
see
to
the
put that answer. Sorry.
I'm sorry.
I wanted to put what Michael put, but I didn't understand because that includes the 2, and since 2 isn't included, I wasn't sure.
Oh, for real numbers, try to draw the picture. Try to draw the picture. Let me use this whiteboard. Right. So let's think about two sets. The first set comes from negative infinity. Oops. Up to 2, right? Let's see here. Let's see, this is a 2. So, all the way down, from 2 all the way down. The second set, let me use the red color. The second set is from 1. 1 is here, right? 1 is 1 included, 1 included, let's use bracket, up to positive infinity. You see the union of those two? Union of those two is from negative infinity up to infinity, right? Because the intersection of those two sets is from 1 up to 2.
Okay, I see it now.
Okay, all right.
Thank you.
So what if I ask you, George, what is the blue set subtract the red set? Let me write this for you. So that's from, so one set is from negative infinity up to 2. And the second one is from 1 up to past infinity. So my question is, what's the first set subtract the second set? What is negative infinity?
2.
Only one number? We're talking about real numbers. We're on real number 9. The infinite many numbers cannot be finite set.
Right. Then it would be maybe 1 to 2.
1 up to 2.
Yes.
Okay. So my question was from negative infinity up to 2, subtract 1 up to positive infinity. So let's check. So that means this new set is in this blue set, but not in the red set. As you said, that's from 1 to 2, right? From 1 to 2, we would use 1 with bracket, and 2, what about 2? 2, should we use bracket or
Parentheses.
we should use parentheses?
Yes.
Okay, you see this 2 is not in this first set. You see that? Because this is open parentheses.
Right.
Right. So it's in the first one, not in the second. Great. Good job.
Thank you.
All right. Thank you, George. Anyone has any questions? Yeah, whenever we deal with real numbers, I always try to draw the real number line. Really helpful. Okay. Why is the bracket closed? What do you mean? What do you mean the bracket closed? You mean the 2? Oh, because that's in the set. That's in the question. You see this 1? 1 is in the bracket. Make sense? Okay. Okay, now everyone try C. Be careful, this is the and, right? Remember, and represents intersection or represents union. Let's see. Okay, Jin Qi. You want to try this one?
Okay.
Okay.
Wait. What kind are we doing?
You can type in your chat.
Oh, okay.
Yeah. Which one? Hold on a second. I moved. This one, C. 1C. This one.
I'm kind of confused how to do this one.
Okay, let's see. Maria, do you like to help her?
Sure. Okay, so what I did first was that I solved for the first part. So 3x minus 5 is greater than or equal to 1. Did you do that yet?
Yeah.
Okay, so then I got x is greater than 2, and then the second part is 2x plus 3 is greater than 11, and I solved that. Did you solve that?
No, I didn't do that part yet.
Okay.
Okay, Maria, do you have the answer?
No.
Okay, let's see, Michael. Okay, what's your answer, Michael?
I have an answer, but I'm not sure it's correct.
Okay, what's your answer?
2 and 3, but I don't know how to write that.
Oh, is 2 included in it?
Yes.
Okay, then you use bracket. 2, is 3 included in it?
Yes.
Uh,
Actually, it's up to 4, but it's not 4.
up to 4, but
Yeah.
4 is 4 included in it?
No.
No, then you use this. Okay, can you see the chat? Oh, okay. Mino also tapped for you.
Okay, thank you.
Make sense? Okay, all right. Okay, thank you, Maria. Anybody has any questions on this one? Jinqi, does Maria help you?
Yeah, because I only did the first part, that's why.
Okay, okay, that's okay. Okay, now let's do 2. 2, I'm going to give you 5 minutes, then I will call people. All right, so do on your own first, then I will call people for answers. Oh, it's too small. Let me make a. Is this okay now? Okay. Okay. Oh, I'm going to call people, Jinqi. You are trying to answer the first one? Oh, A. Okay, let's say Jinqi. So the complement of A, so we have to look at the universal set. Universal set is from 0 up to 10, whole numbers from 0 up to 10. So the complement of A means the members not in A, but in the universal set of U, so which are 0, 2, 5, A, and 10. I agree with you. And B, complement of B means the elements in U, in B, but in U, but not in B. So that would be 0, 1, 2, 3, 7, 9, 10. Yeah, I agree with you. Oh, so A bar means A complement. So that's relative idea. So A is a subset of U. We have universal set. Universal set. So A bar means U minus A. So A complement. Usually we use this equals to universal set minus the set. All right. So the elements in U are not in A. So or think about this way, Arden. A plus complement A equals to the universal set. Type in the chat. So a set union its complements always equals to universal set. Remember when we talk about the complement of a set, we always refer to a universal set. So B, oh, okay. A intersect its complement. Think about it, what's a complement? The complement of A are the elements in U in the universal set and not in A. So A intersect its complement always. Let's see if anybody can figure out C. C has a beautiful answer. And it's obvious if you think about its definition of the right empty set. Right, empty set, yeah. Any set intersect with its complement is empty set. And any set union with its complement is what? The next one, D. Set A union its complement, always the universal set. Great. So C is empty set, and D is a universal set. Good job. Okay, now let's look at E. A subtract its complement. What's A subtract its complement? It's A itself. Well, same thing. If A complement subtract A, that would be A complement. Okay, F, G, H. So I'm leaving F, G, H. Let's see if we have volunteers to do F, G, H. Okay, Amy has, this for F, A complement, subtract B complement? Okay, so A complement, and we listed, Jinqi listed before, subtract B complement. All right, anybody has different answers? All right, let's try to figure out. Let's try to figure out A complement. Okay, Amy, what's your A complement? Oh, Aja, for F. We're talking about F now. So we need to find A complement, then we need to find B complement. Okay, 0, 2, 5, 8, 10. Good. Okay, A complement. What about B complement? Zero, 1, 2, 3, 7, 9, 10. Great. Now we're looking for A complement subtract B complement. That means the elements in A complement, but not in B complement. You can look for the intersection first. Think about the A complement intersect B complement. We're talking about F, question F. So A complement intersect B complement. 0, 2, 10, right? Okay, so now the element in A complement, but not in B complement. So that means you just do A complement subtract the intersection of A complement with B complement. Think about A complement 0, 2, 5, 8, 10. But 0, 2, 10 is in B complement. 5 and 8 not in B complement. Does that make sense? That's why the answer is 5 and 8. Okay, all right. Anybody has any questions for F? All right, G and H, 5 and 8. So A complement subtract B complement equals to the set has 2 elements. Okay, I tapped in the chat. Lino has answer for G, right? So A union B complement. Well, what's A union B? A union B, we have 3, 4, 5, 6, 7, 9, and 1. And its complement means it's in A and B, but not in U, which is 0, 2, and 10. Yeah. Yes, I agree with you guys' answer. Okay, Aidan is asking, why is it 5A if we are subtracting from A? No, from its complement. You missed this question. Okay, see, F is A complement subtract B complement. And the A complement, Amy wrote here. Let me see. So this one is A complement. A complement equals to this. And this one is B complement equals to this. Okay, I then tap in the chat. So A complement equals to this set. B complement equals to this set. Then let's figure out A complement intersect. I don't know how to do intersect. So A complement subtract B complement. Are those members in A complement but not in B complement? Which is 5A, because you see 0 to 10 in both, right? All right. So, okay, G. All right, we've got a G. And the H, what's H? H will have A complement intersect B. A complement intersect B. What's the 5, 6, A, 4? 5, 6, A, 4. So just 5, isn't it? So A complement intersect with B is just 5. Then the complement of it is everyone else except 5. It's a 0, 1, 2, 3, 4, 5, 6. No 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Or Moses doesn't have 8, except 5 and 8. A is also in B, yes. So the intersection of A complement and B is 5 and 8. So then you subtract that. So it's everybody else except 5 and 8. So yeah, Moses' answer is right. So for H, the answer is 0, the set of 0, 1, 2, 3, 4, 6, 7, 9, 10. Great. Great, good job. Okay, now we're on 3. So 3, let's share this area. So we have A subtract B, then intersect with C. Right? So A subtract B. Well, we say A is here. Subtract B is only this. So we would have this part. Then intersect with C is this part. I cannot shade. I don't know why this file does not allow me to write on it. Yeah, I cannot write on it. Do we see this part? Do you see my pointer? Oh, you see my pointer. Okay, great. So for A, we see this one, right? See this one. So A, oh no, not that one. A subtract B, because we have a subtract B. A subtract B is this part. It's this part. Then intersect with C. So just this part. Just this part. Okay, let's see B. A union B. A union B are those two circles. Then subtract C. That means the elements in A union B, but not in C. Right? Not in C. So follow my pointer. So at this, and this. Not in C. Okay. All right. Anyone has any questions? Oh, you cannot see my pointer? But someone can see my pointer. Okay. I see. Okay. Because this work, you have similar homework. Try on your homework, all right? Because this screen does not allow me to write on it somehow. So let's quickly go to 4. Then, but the question gets more and more difficult. Let's quickly go over 4. So for 4A, we want to find the union of these 4 sets. We have A1, A2, A3, A4. And B, we want to find the intersection of those 4 sets. Okay, I think, let me see. Yeah, if you have your answer, you can tap into the chat. Okay, great. I didn't see, not for B, we didn't see. What do you mean? Adam, what do you mean? You don't see the question? Oh, A4. Oh, you didn't see A4. Let me minimize this. Okay, so the notation is saying we want to find the union of A1, A2, A3, A4. So this notation is a shorthand notation. This is A1 union A2 union A3 union A5 union A4. The second one is the intersection. A1 intersect with A2, intersect with A3, intersect with A4. Okay, Moises is saying A, the answer for A is A, B, C, D, E, F, G, H. I agree with you. But because the union, the set of union has to include all elements in the 4 sets. A, B, C, D, E, F, G, H, right? Xiaomi, you're missing F, G. Because so F, G is in A1. So the union has to include every element in every set. Okay. So intersection are the members in every set, are the elements in every set. Moises is saying that's A and B. Yes. You say only AB is in A1, A2, A3, and A4. Okay, great. Anybody has any questions? All right, let's go to those just additional ones, right? Let's just make sure everybody clear on the previous one. Everyone has any questions so far? Okay, if not, let's go to the little bit challenging one. So let's say 1. Suppose A is a set of 0, 1. B is a set contains 1 and 2. So find A cross B intersect B cross B. Okay, let's do A. Everybody do A. Let's see then type your answer into the chat. Okay, Xiaomi already have answer 2 ordered pairs, 1, 1, 1, 2. Let's see. Yeah, I see. And then don't worry about them. You know, take your time. Try to understand. It's most important to try to understand what's going on, not to compete with the speed. Yes, I agree with you guys. So 1A is a set contains 2 ordered pairs, 1, 1 and 1, 2. Okay, good job. Okay, now let's try to do the union B, the union of A cross B, union with B cross B. 0, 1, 0, 2, 0, 1, 0, 2, 1, 1, 1, 2, 1, 1, 1, 2, 2, 2, yeah, I agree with Xiaoming's. 0, 1, 0, 2, 1, 1, 1, 2, 2, 1, 2, 2. Okay. Yeah, I agree with Xiaoming's. Because A cross B, we have four ordered pairs. And B cross B, we also have 4 elements. But then 1, 1, 1, 2 is a common one, right? So I'm left with 6 ordered pairs. Okay, good job, guys. And the rest of it, a little bit challenging, okay? You may try yourself. And the number 4 is just for precalculus, right? Just for fun, all right? So focus on your homework. Focus on your homework. So today we talk about intersection. We talk about intersection. We talk about union, intersection, difference, and the complements of sets, right? Then we talk about the shorthand notation, and that's all. So do your homework to get familiar with these ideas. All right, and I see you tomorrow. Anyone has any questions? Yeah, totally we have 10 homework. Yes, except midterm and final. Because the total we have 12 meets. So 12 meets. One meet is on 12 is midterm. Another meet is the last day of class. So any other 10 meets, we have 10 lectures, 10 homework, 10 classwork. So everything is posted on Blackboard. Okay. Yes, submit before class time, before today. It's better to try to finish if you have time, if time works for you, try to finish at night. That's okay. That's okay. Yeah, try to submit before class time. Then you get full credit. Then afterwards, you can still submit, but you won't get full credits. Of course, Aidan, if you want to get textbook, you think that works for you, yes, go ahead. And also, if anytime you have a problem, you can check with YouTube. You can also check with YouTube. You can rewatch our class recording, or you can check with YouTube. Yes, there's a link in the link of a textbook in the syllabus. Yes. Okay. Any other questions? Yeah, you have a group study, right? Is there a group chat? How to make a group chat? Yesterday they were talking about among yourselves, right? You have phone numbers. Okay, guys. See you tomorrow. Have a good night.